Welcome back to part 2 of Module 4, Lesson 6, where we're dealing with computing with scientific notation. This will be the very last video in this module. Yay! To add and subtract numbers with scientific notation is helpful to rewrite the numbers so that the exponents of each power of 10 have the same value. So here we have a problem that says to add 3.6 times 10 to the fourth to each of the three numbers shown below. Each number needs to be rewritten so that its exponents of each power of 10 are going to be the same. Drag the correct expression to show each number written using an exponent of 4. So for the first one here, we have 1.43 times 10 to the third. That means to make it to the exponent of 4, I'm going to have to move the decimal one space to the left. So that's going to be 0.143 times 10 to the fourth. This one right here is an exponent of 5. So to make it 4, I'm going to have to move the decimal one space to the right. So it's going to be 14.3. Next, we have 1.43 times 10 to the 2. We have to get it to be 10 to the 4. So we have to go 2 spaces to the left to make it 10 to the 4, which is going to give us that one, which means this poor lonely soul is not going to get used. So sad. Now I know it can be a little fuzzy and confusing figuring out which way to move the decimals for that, but just go back to think about the lessons we've had on scientific notation and how if you bounce a decimal to the left, the exponent goes up. If you bounce the decimal to the right, the exponent value goes down. Once numbers written in scientific notation have the same exponent on their power of 10, then you can use your distributive property and add or subtract. So here I have 4.36 times 10 to the fifth and 2.09 times 10 to the sixth. So we either need to change this one so that it is a 10 to the sixth, or this one so that it is a 10 to the fifth. And they chose to change the second number. They wanted the decimal to go down, so since the decimal had to go down, they had to bounce it one space to the right, which gave them 20.9 times 10 to the fifth. Now we have 10 to the fifths on both, so we're going to pull the 10 to the fifths out using the distributive property. Yes, I know they haven't really taught that to you yet, but we're going to use it anyhow. And then the 4.36 and the 20.9, they go together right here. From there, we're going to add it to get 25.26 times 10 to the fifth. And now we have to change it back to scientific notation, which means that decimal has to be after the first two. And when you move a decimal left, your exponent value goes up, giving you 2 and 526 thousandths times 10 to the sixth for a final answer. Now maybe the textbook will slow down just a little bit in their explanation of this one. For this one you have a times 10 to the ninth and you have a times 10 to the eighth. That means we either make this one a 10 to the eighth or we make this one a 10 to the ninth. And in the end it really doesn't matter, I don't think, which way you go. So let's see what they end up doing. The textbook decided they wanted to use 10 to the 8th, and like I said, you could have gone the other direction. It would have given you the same answer in the end either way. So for that, in order for the decimal to go down, for the exponent to go down, the decimal had to move right. So they moved the decimal one space to the right, giving you 14 and 5/10 times 10 to the 8th. Now that they have the common power of 10 here, we can go from there, pull out the 14.5 and the minus 2.84, and then outside of that, outside the parentheses, all that's going to be multiplied by the 10 to the 8th power. Once again, that's using the distributive property, which they still haven't taught you. From here, we're going to subtract these two numbers. That's going to give us 11 and 66 hundredths times 10 to the 8th. But we can't be finished yet because we have to end where that decimal is after the first non-zero number. That means I'm moving the decimal left, and when you move the decimal to the left, what happens to your exponent? It goes up. So your final answer is going to be 1 and 166 thousandths times 10 to the ninth for the final answer. And if it gives you a warm fuzzy feeling, you can go ahead and type it in that box right there. Now it's going to be your turn to solve a problem. evaluate the addition of these two scientific notation numbers, and put your final answer in the box. Go. Well, to start off, we have to decide, do I want to go up with 10 to the 4th or down with 10 to the 5th? I think I'm going to go up with 10 to the 4th this time, because I think that'll help me get a final answer where I don't have to do any other math afterwards. So if I want to go up with this, make that a 5, so that I'm having 10 to the 5th here, that means my decimal has to move left, right? So now I have 0.689 times, so I have my times there, 10 to the 5th, plus 9.24 times 10 to the 5th. From there, we're going to take and use the distributive property. 0.689 plus 9.24 goes there, all times 10 to the 5th. Come off to the side for my grunt work. 9.240 plus 0.689. Add those up. 9, 2, carry the 1, 9, 9, decimal comes down, and that's going to give me 9.929 times 10 to the 5th. That decimal is in the exact space it needs to be, so if I did it right, that's going to be the final number. Bring the textbook back up, and we got, what was it, 9.92, what was that, 9.929, yep, times 10 exponent 5, accept and check, and the answer checked. Because I had set my problem up to where the exponent would be right, excuse me, the decimal would be in the right space when it was done, I didn't have to move anything. But if I had ended up going to the 4th with this one, I would have had to do some shifting back so that everything lined up properly with the decimal and the final answer, so it would qualify as being in scientific notation. We're going to finish off with an apply problem that says in a recent year the world population was about 7,289,322,000. The population in the United States was about 3 times 10 to the 8th. About how many times larger was the world population than the United States? Now, to start off with, you got that little word there, times, and that word may get you in trouble because you may think that you're going to be multiplying in this problem, when in all reality you're going to be taking and dividing it. So let's get over here and get things pasted in so that we can get our problem working. And we have the option that we can take and change this to scientific notation, or we can take and work it as a standard form problem. There's a really important thing going on here though, and that important thing, that important word that I want to point out to you is right here. It says about, and because it says about, I'm going to take that number right there and I'm going to go 7, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. I just abouted that number to something that's a little bit more usable. Now I'm going to take it and change it into scientific notation by going 1, 2, 3, 4, 5, 6, 7, 8, 9. Put the decimal right after my first non-zero digit. So it's going to end up being equal to 7 times 10 to the 9th. Now that's the world population, and it wants to know how much larger the world was in the United States. So that means I have to take that 7 times 10 to the 9th and divide it by the United States population, which was 3 times 10 to the 8th. From there, we're going to break it down into two different parts. I can do 7 divided by 3 is one part, times 10 to the 9th divided by 10 to the 8th. With that done, we're going to say 7 divided by 3, that's going to be, now we're just 2.3 is an approximation, times, and then I have 10 to the 9 minus 8, which means now I got 2.3 times 10 to the 9 minus 8. Well, that's just going to be 10, which means when you multiply 2.3 times 10, you're going to find that the world's population is about 23 times that of the whole United States. So let's go back and see if they give us an answer that looks like that. I'm going to say about 23 times, check my answer, and they did their math the same exact way I did. You all stop your video here, get started working on your homework, bring me any questions you have in class tomorrow.